This meeting is being recorded.
For problem 13 from chapter 3, we are given 4 compounds, A through D here, and each compound has 2 protons, which are color-coded, red and blue. And we're asked to determine between these 2 protons, which is the more acidic proton. And these are not color-coded to show acid and base, red and blue, so we can't use that to help us. But we can use some periodic trends such as electronegativity or atomic size. So let's take a look at A here, and the protons are connected. The red one is connected to a carbon, and the blue proton is connected to an oxygen. So since they're in the same row of the periodic table, we can compare their electronegativity values, and oxygen is the more electronegative atom, so it's able to stabilize a negative charge better than carbon if it were deprotonated. So in that case, the blue proton connected to the oxygen is expected to be more acidic than the one connected to the carbon atom. So let's take a look at B, where we have protons connected to, or one connected to carbon, and then one connected to our nitrogen atom. So these are again in the same row of the periodic table. So we will compare their electronegativity values. Nitrogen is more electronegative. Remember our general trend, just who's closer to fluorine. And therefore, nitrogen can better stabilize that negative charge that will be generated upon deprotonation. So the blue proton would be considered the more acidic proton than the proton connected to the carbon atom. So let's take a look at C here. And now we have a proton connected to a sulfur atom and an oxygen atom. So this is the first time these 2 atoms are not in the same row. They are in the same column, the same group. So now we must compare size. So for these, we compared electronegativity. This is the first time we're going to compare size. So sulfur is larger than oxygen and therefore can better stabilize the negative charge that results upon deprotonation. So this more stable, weaker conjugate base would indicate a stronger parent acid. So that means that in turn, this proton on the sulfur atom is more acidic than the proton connected to the oxygen. So in our last example here, we have, again, an oxygen connected proton and then a nitrogen proton over here. So in this case, again, we're going to compare electronegativity, and we know that oxygen's more electronegative than nitrogen, able to better stabilize that negative charge that results upon deprotonation. So therefore, once again, the weaker conjugate base that is more stable would then indicate a stronger parent acid. So this proton over here connected to the oxygen atom is expected to be the more acidic proton.